Hello ladies and gentlemen. Today we're going to talk more about linear functions, and what we're going to do is actually how to write a linear function from a multiple number of situations. The first thing is the formula for a linear equation, y equals mx plus b. Remember that. That's something you're going to see quite a bit over the next 4 or 5 months. In that equation, first thing is x. X is your domain, your x-coordinate, your independent variable. Y is still going to be your range, your dependent variable, your y-coordinate for a point. This m, the coefficient in front of x, right? That is your rate of change, that change in y over change in x that we've talked about before, right? We also call it the coefficient because that is the number in front of your domain. Right? B is known as your constant. It's your initial value in a problem, what you start with. It's or a one-time fee. All right? It's what's being added on to whatever is changing. All right? This symbol, that delta y over that delta x, what it means, the vertical change divided by the horizontal change. In other words, your change in your value of y divided by your change in your value of x. That's what it stands for. Now, we're going to use this process table to help find the equation in the form of y equals mx plus b. If you're given a table, you should be able to find the equation, especially from what we did when we did our patterns. The idea is that when that process column, we're going to write everything as mx plus b, just like we did with our patterns. It's the same basic idea. Except for now we're going to start giving some names to these things. And whenever you're doing this, if you're asked to write the equation of a line, you need to find two things. You need to find your coefficient, your rate of change, and you need to find your constant, that's b. Find both of those and you can write the equation of any line. Well, when we look at this, find the change in y over change in x. Real simple. Find your value of y. How do you get from -9 to -1? 8. -1 to 7, 8. You can try x. How do you get from -3 to -1? +2. -1 to 1, +2. So your change in y over change in x, the same thing that we have down here, is 8 over 2, which equals 4. Always simplify it as far as you can. So in this case, in this process column, m, your rate of change, is 4. You multiply that times the domain. And you would do that for each one. You can do that throughout. But now, just like we did with our patterns, you need to now find the initial value, the constant, what you're adding on. And you do that just by saying that when you plug -3 in, you should get -9. Well, 4 times -3 is -12. -12 plus 3 gives you -9. On the next one, -4 times the -1 gives you -4. -4 plus 3 is -1. So if you notice, your constant will always be the same. Your constant in this case is 3. So as we write this, as long as you know the value of m, the value of b, you write the equation in this linear equation form, y equals mx plus b. So you'll start with y equals, instead of writing an m, you'll write a 4 times x plus 3. So the equation of this line, if you were to graph this, would be y equals 4x plus 3. Next. You might be given a table in this fashion. Again, we're going to write the equation in this form, y equals mx plus b. This is kind of hard to look at. So a lot of people, what they'll do is they'll write one out like this. So the x value, 0, 2, 4, 6, 8. The y values, -3, -2, -1, 0, and 1. Same idea. When we look at this, find your value of m, the coefficient. Find your value of b, the initial value, your constant. So to start off with, change in y. -3 to -2 is 1, -2 to -1 is 1. You can do that all the way through. You see it's always 1. For x, it's changing by 2 each time. Alright, so you're changing y, we're changing x. Changing y is 1, changing x is 2. Well, 1/2 is as simplified as you can get. And we leave it as a fraction. Do not change it to a decimal. Leave it as 1/2. So your value of m, your coefficient, is 1/2 at this point. That is what we put in that process column. So 1/2 times the value of x, so the domain, is 0. Well, 1/2 times 0 is 0. So minus 3 will give you -3 for the next one. 1/2 times 2. You can use your calculator or whatever you want to do this, but half of 2 is 1. Well, 1 minus 3 gives you -2, and you can do that throughout. What you're going to notice is that constant will be the same. So your constant in this case is -3. If you wrote the equation again, y is equal to m, which is now 1/2, times x, and then a -3. We put -3. We don't put plus -3. We write -3. Now, something I want you to notice. I want you to notice what your initial value is. I want you to notice something over here. Here. When you look on a graph, or you look at this, your initial value is really easy to find when you look on a table if you know what x is. Whenever x is 0, your y value will be your initial value, just like we have here. Wherever x is 0, your y value is your initial value, your constant. All right? Remember that. That might come up sometime. Next one. If you're given a set of points, a set of ordered pairs, you still might be asked to write the equation of a line. Well, take those points, put them in table form. 3, -3, 6, -9. You can use these to find this. So again, start off with, you need to find the coefficient and you need to find the constant. Then you can write the equation of a line. When writing this point, changing y. 5 to 3 is -2, -3 to -1 is -4, -2, -6, so on and so forth. You can go through these. So, next, how do you get from -1 to 0? 1, 0 to 2, 2, 2 to 3, 1, 3 to 6, 3. When you do any one of these, you're going to get -2 over 1, which is -2, -4 over 2, which is -2, so on and so forth. So you do have a constant rate of change here. The rate of change, changing y over changing x, when simplified is -2. So again, in that process column, this is the function in linear form, mx plus b. So the rate of change is -2 times the value of x, which is -1. So -2 times -1 is a +2. 2 plus 3 gives you 5. All right? I want you to also notice here, where your value of x, that's going to be your y value, is going to be your constant. So your constant in this case is 3. So as we go through, y equals m, which is -2x, plus b, which is now 3. So that's the equation y equals -2x plus 3. Alright. For some reason this messes a lot of people up. And I don't want this to mess you up. But when you look at this, it says, write the equation of the linear graph shown, okay, from what we've done previously. Well, you've got a set of points on a graph. You have a set of ordered pairs, just like this one. So with that set of ordered pairs, just write them out. The first one, -6, -6. You have one at -3, -3. You have one at 0, 0. Another one at 3, 3. And one way over there at 6, 6. Those are all points. Those are coordinates that you can use. Now, same idea. Find your rate of change. your coefficient, and also find your constant, your initial value. Hopefully, you started to notice, hey look, initial value, where x is 0, the y-coordinate is your initial value. Start to know that. Now watch. Change in y. Get from -6 to -3 is 3. 3, 3, 3. Over here, same idea. -3 to 0, 3. 0 to 3, 3. 6 to 3, 6 is 3. So your rate of change is 3 over 3, which is 1. So that mx plus b. So watch carefully to see how we write this one. So m is 1 times -6. Well, what's 1 times -6? -6 is what you have. That's why we're adding on 0. 1 times -3. It's -3 plus 0. Now, how we write this in terms of x. Y is equal to. Now, it says 1 times x. Well, there's a way we write 1x. We just write it as x. We assume that is 1x. The other thing is adding on 0. If I put a plus 0 here, does that change its value? If I do 5 plus 0, it's still 5. So adding on 0 does not change the value, so we don't put it. So your answer to this problem, the equation is y is equal to x. Remember what this one is. This is your linear parent function. You plug in a value of x, you get the exact same value of y. Alright? If x is 5, y will be 5. If x is 3, y is 3. That's the simplest form of a linear function. Linear parent function. Remember that. Alright, so we got a couple of examples here. So, on your sheet, what they want you to do, say I want you to fill out the representations for each of the linear functions. So, Lana ran tie-dye booth at a local carnival and it cost her about $360, buy supplies, and she sold the shirts for 15 bucks. She would complete the information shown in the relationship between S, the number of shirts sold, and P, the amount of profit. So, how we do this? When you have something like this, you start off with what we want to try to find the starting point, your initial value. So, S, we start at 0. The reason why we start at 0 is because that tells you she has not sold any shirts. She doesn't sell any shirts. When we look at this, where's her money? $360 she's paid so far. Alright, she wants to see how much profit she's made. So, from there, she sells one shirt. Are you going to add or subtract from that? No. You're going to subtract from that amount because she had to pay for that. So from there, you're going to go to $345. 2 shirts, again, subtract 15. That goes to $330. 3 shirts, again, same idea. Hopefully you start getting the picture. $315, so on and so forth. Well, we want to write an equation from this. When you fill this out, you start at 0, 360. 1 and 345. Right about there. 2, 330. Sorry. 3, 315. So on and so forth. You can do this all the way down. 4, 300. 5, 385 or 285. So on and so forth. All right. And again, hopefully you're drawing only points. This is discrete, not continuous, all the way through. So, again, the 2 things you need to know. Changing y over changing x, which is your value of m, and also your initial value. Well, you found your initial value right here, 360. Your m, your rate of change, negative 15 for y, 1 for m. So it's negative 15 over 1, which is negative 15. So we'll write the equation, y equals negative 15x plus 360. Okay? That's one example. Let's take a look at another example. So you're going to use the information and all the representations to fill in the missing parts. So Mackenzie rented a pair of skates for an initial fee of blank. We don't know yet. She must pay an additional blank per day. After 6 days, how much will she owe Rouse Rentals? So we have some points here. The points are what are going to help you out the most. We have a point here at 0 and 8. Alright? So, one thing you can tell here is you can find your rate of change. You can find your rate of change because they gave you a point. How do you get from 8 to 11? 3. 0 to 1, 1. So that means this one has to go up by 3 also because this is only going up by 1. So that's 14. Up another 3, 17. This is what we just did with our patterns. 20, 23, alright, so on and so forth. So here, if you notice, your rate of change, change in y over change in x, is 3 over 1. So your rate of change, your coefficient is 3. You should be able to find your initial value. Your initial value, again, is where the domain is 0. So the dependent variable, in this case, 8, is your initial value, your constant, b. So the equation is y equals 3x plus 8. Now to fill in the information, she rented a pair of skates for an initial fee of, there it is, your initial fee, $8. She must pay an additional, well, what's it changing by each time? It's changing by 3. So she's paying an extra $3 per day. If you want to know after 6 days, well, what are you going to do here? Add on another 3. So hopefully, you're going to say, she's going to pay an extra $26. Alright. Hopefully that gives you some multiple representations of what linear functions look like. How to write the equations from those things. Whether given a table, a set of ordered pairs, a graph. This is all the type of things we're looking at. Alright? So, come in on Wednesday or Thursday, whichever day. Come in with any questions. You're going to have to do kind of some of the same things that we're doing here. Have a great evening. Goodbye, everybody.